Today, my talk is about the wearable system design toward human-centric computing. So if you remember that this is the first PC back to 1981. This is the first PC looked like. But once the technology evolved, we have smaller IC, more powerful IC, and also more low-power IC, so you can crank everything into the tiny, tiny transistors, ICs. So if you heard about Moore's law, that you can crank in double of the number of transistors in the same size of chip every 2 years. And then the past 40 years, we have witnessed this involvement. So you might be wondering, okay, now we have very small smartphone, we have this earpod. What is the next? You probably can guess. Yes, there's a metaverse. So what do we mean by metaverse? And we think that human-centric computing is the key for metaverse. So what do we mean by that? First, we need to have sensation, connection between a wearable device and also human sensation. For example, you want to know what does it mean from human sensation, and how do we use the wearable device to trigger or kind of stimulate the human sensation using wearable device. This is what we call a high bandwidth human-to-machine interface, and also high bandwidth machine-to-human interface, just bidirectional. And not only that, we also need to have some sort of AI, because if you have biological signal from your body, how to interpret those signal, and how to make machine understand the signal, that's the key, called contextual AI. So I already mentioned about the high bandwidth human I/O, and also mentioned about AI. But another thing is that we want to make sure this device, you don't need to learn it. For example, even today's a smartphone, even my mom asked me, should we one click or double click? Even one click, two click, you still need to learn. But how about a new device? You don't need to learn. For example, just like using your hands, your brains, or your foot, it's a nature signal. So we want to using AI to harvesting this nature signal, make the people using metaverse no need to learn. That's our goal. So to do that in the reality lab, we have several demonstrations. Although they are just baby steps, they are just simple demonstration. But we're getting there. So for example, one demonstration we have is called haptic display. We can building bubble, building actuator in the tiny glove. And you can send, for example, the liquid or air. You can kind of activate your bubbles right next to your fingertips. And you can feel the virtual object, no matter it's a VR or AR environment. I think we believe that it's a very important step that you can feel the virtual object. When you're wearing the glasses, when you're wearing the glove, you can feel something in the virtual environment. Another thing we have done is called EMG signal. Is that EMG is a muscle signal from your spine, your brain, your body, and then to your wrist and also fingers. So instead of using your finger to move, we already can harvesting your EMG signal and try to using AI to interpret your EMG signal. So for example, in this case, when you move your finger, even just a tiny, we understanding you are trying to move your fingertips or thumb, and using that as a signal, you can grab something like this in the VR or AI environment. So again, this is just a simple demonstration, but we are kind of working toward that direction, toward the metaverse. So what is the key there? So if you try to imagine, if you really want to enter the metaverse, long-time use actually is the must, because you want to enter the world not just for 30 minutes or 1 hour. For example, we want to make sure that you can work, you can even live in the metaverse. So it need to be long-standing time, for example, maybe 8 hours for a day. So you can really work in that world. So the all-day wearability is the key. And also the contextual AI, as I mentioned, how to interpret those signals, and also translate between machine and to human interface using AI is really the key here. So, but what's the challenge today? So if you see our recent product, Quest 2, but definitely yesterday if you see the Meta Connect, we just announced a new Meta Pro. It's a lighter, better device, but for today's device, still quite heavy, and also quite not easy to wear, to be honest. The reason because for today's component, it's all rigid, all need protection. So you need a metal frame and also plastic to protect this delicate devices to make sure it does not break during the use. Another challenge is the power, because this is a battery and sensor, they all drain the power. So you need a big battery to support the functionality. How do we solve the problem? And I think here many intelligent engineers and scientists, we are here to solve those problems. And this is what we're seeing right now. So one possibility from our point of view, using flexible electronics, that's why I'm here, because I talked to many of you to do the flexible electronics. So one demonstration